My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 514. In this lecture, we will try to understand Kartz centrality. Does the person follows back? Imagine if you are trying to compute function called follows underscore back a comma b, where a comma b are two vertices. If there is an edge from b to a, if there is an edge from b to a, what is b? Vertex b to vertex a, isn't it? Now you try to predict, is there any edge from a to b? Isn't it? That is our intention. We have to predict whether there is any edge from a to b. What you are trying to predict is, if somebody gives data point a comma b and asks us, should there be an edge from a to b? The feature that we can engineer is, there could be an edge from a to b. There could be an edge from a to b, because b is friend of a, b is follower, isn't it? B is follower of a on an Instagram type of thing, isn't it? Even Instagram type of network, isn't it? There is a very high chance that a is also friend of b and a could follow b. So very simple feature, and again this is super useful feature. It is super simple, and literally it is if else condition. It is very powerful idea. So the feature says, if there is an edge from b to a, so you are trying to compute a function given a comma b. Now you are saying that if there exists an edge from a to b, return 1, otherwise return 0. Very simple. This is called follows back feature, isn't it? What is this feature? This feature is called follows back feature. Follows back basically asks you, you are trying to compute function between a and b, isn't it? Trying to predict this edge from a to b, isn't it? It is trying to predict edge from a to b. Is there any edge exist between from a to b? The other feature that we wanted to introduce is Kartz centrality. It is very simple to what we learned. It is very similar to what we learned in page rank algorithm, isn't it? So Kartz centrality, slightly older algorithm. It is from 1953. In a nutshell, what it does is, there is a very simple nice explanation. Suppose if you have a social network of people influencing the other people, Kartz centrality in a nutshell says to evaluate how important a person is to measure the influence of one node or one person. You take the influence of all the neighbors, just like page rank, isn't it? Influence of Jose depends on the users who are connected to Jose. Indirectly, influence of Diego depends on Agenta. Just say, if you consider again one more vertex, Diego influence depends on Agenta Jose, isn't it? Diego depends on Agenta including Jose. Very similar to page rank algorithm. There is very similar to Google's page rank, or to the idea of eigenvector centrality, isn't it? It is similar. So this is an alternative measure of Google's page rank, which is slightly older and has been used in the past. It is slightly older method and not a recent one. Let's experiment Kartz Centrality also. Why not? Because it is readily available in network X. So we compute the Kartz Centrality. We compute the Kartz Centrality for each of the nodes, isn't it? For each of the nodes, or for each of the vertices, and you get minimum value, maximum value, and mean value. Very simple. It's a very simple stuff, nothing very fancy. So if you want to learn more, there is a full-fledged Wikipedia article on how Kartz Centrality works. But for the purpose of this case study, it's good enough to understand it is very similar idea to PageRank. This is another feature that we will use in addition to follows underscore back of A comma B. Just go through this lecture. If you have any difficulty, please keep a comment. In my next lecture, I will discuss about hits score, which is one of the important score. That is, what is this concept? Hit score. Thank you very much.